Hello, I'm Connor Sullivan, and I'm just going to do this because I don't know what else to do for my astronomy oral final because our meeting, there's no link or anything for it, so I think I'm just going to explain what I know so far. And I just start off with saying astronomy is the study of objects that are like beyond Earth, the stars, the planets, things like that. And then for the first few assignments, we were doing some math, and then I can just think about it like this. If I did 4.29 times 10 to the 5th power, like that, it might be a little backwards. If I did that, it would be, because we're just moving the decimal to the right 5 times, I'd do 429, and then I'd move where the decimal is in between the 4 and the 2, I'd move it over 5 places. So 1, 2, 3, 4, 5. And that would get me 429,000. If I were to do that with a negative number, say 2.82 times 10 to the negative 4th, I'd move that decimal over to the opposite side, which in this case would be the left, and it would be 0.000282 for my two final answers. We also talked about, I believe the zenith is the highest point in the sky, about that, and then the stars, they move in a circular path, more like an oval almost. And then June and July, the sun rises kind of northeast area, and in the northeast area for the sun rises. And then if I were to judge a star and where it would be depending at 6 p.m., say it was in the east, it would move at 6 p.m. probably. It would probably be almost above, but not fully above myself. And then say we move to 12 p.m., the star from the east that started on the east and moved to 12 p.m. would be basically almost fully to the west. And then AU stands for astronomical unit. And then I don't know if I'm saying this right, but Ptolemy, they just basically, the summary of that was the theory of that or whatever was astronomers and scientists kind of figured out that it could not explain planetary motion, and then Kepler's one just kind of increased that and made it more valuable. The Kepler's one was the better idea. And then for the moon, how do we know moon's gravity and stuff? The astronauts are actually following towards Earth, but they're also so fast in orbit. That's how the gravity is a little less dense up there, and we can float, so to say. And then also earlier in the thing we learned about in astronomy, we learned about Kepler's law, and I kind of remember this based on the shape for law 1. Number 2 law would be speed, and then the third law would be distance versus time. And Kepler's first law, the law of ellipses, it basically just talks about how the planets orbit the sun in more of an oval shape rather than a circle shape, I would say. And then law 2, the law of equal areas, I think, something like that. But it's kind of the further you are away, the slower the rotation is. And the closer you are to the sun, the faster the rotation is. And then the last law, the law of periods, the farther away, it kind of makes sense, the farther away you are, the orbit is longer. Just when you think about how close planets are to the sun, it's slowly getting away. It's getting larger and larger. And then the sun is one focus away. And then, I would say that for kind of the beginning of the whole entire thing. And then kind of towards the middle, I kind of talked about a little bit. Gravity is the mass distance, and then the rotation is a full 24 hours, and then a revolution is 365 days, which is 1 year. And then there's different wavelengths. There's one radio, microwave, infrared, and then visible, ultraviolet, X-ray, and gamma ray. And those go in order of what I said, I believe, from longest to shortest wavelengths. And then for colors are a little bit different. Colors would be red, orange, yellow, green, blue, and then I think violet. And those also go from what I said, longest to shortest wavelengths. And then what else? What did we learn in the middle? Just like maybe, lunar eclipse is when the sun is right here, the earth is kind of blocking the moon that's over here. So when the sun's like rotating, sorry, I'm using my hands, the sun rotates, the earth's in between the sun and the moon. And then for solar, it is sun, moon, earth. So the moon is actually covering it up for our solar eclipses that we get. And then, yeah, the longer the wave takes lower energy, and then the shorter the wave, it's like faster, like higher energy. And then for planets, there's terrestrial, which are also the rocky planets. Those are Mercury, Venus, Earth, and Mars. And I know Venus is really hot, maybe the hottest planet, I can't remember, but then Earth is where we live, obviously. And there's also gas giants like Jupiter and Saturn. And then there's also the ice ones. Those are Uranus and Neptune. And then we can talk about Earth a little bit. Its crust, and then the mantle, and then the outer and inner core. Those are also pretty important. And then the Earth is kind of made up of nitrogen and oxygen. And then what else? Oh, there's the solar nebular theory, where this is kind of how it started or whatever, the universe, so to say, 4.6 billion years ago. And it started with a gas and a dust cloud, and then that kind of collapsed, and that created the sun. And then some disk and dust started to form, and then the planets started to form, and that's kind of like the quickest way I'd say for solar nebular theory would be that one. And then I think that might have been it for that middle part. And then also, I think I forgot to mention, I kind of said in the beginning, but gravity needs mass and distance for it to work. And then there's another thing we kind of learned about too in the middle assignments would be the Doppler effect, and that just like and observes the different wavelengths or the frequency of objects like toward each other. Like the waves, I believe, get compressed, and then when they're moving towards you, they get shorter and shorter as they're compressed. And like a good way I think of the Doppler effect is kind of a car with the sounds. That might be a little better way of explaining it, just because like as a car like drives by you super fast, you're able to hear the different, like it's pretty fast and it's pretty loud, like the wavelength, I would say. And the compression is faster and shorter, just driving right by you as you're closer. But the farther away you go from the car, like you're going to hear that sound for longer periods of time, but it's also going to be like less compressed, I believe. And then speaking of stars, there's the HR diagram, or the Hertzsprung-Russell diagram, I believe, which is just a graph that plots the star's temperature versus their brightness. And we actually did that in the studying lab stars. And then there's different types of stars. We talked about, I know the main sequence, those are like our normal stars. And then the giants are our older ones. And then the supergiants are our largest and brightest ones that we have in the sky. And then the white dwarfs are just like the leftover core that we get from other planets or stars that die, I know. And then there's also the star formation like process kind of. And those ones are a little different. The nebula, I know, those are gas and dust clouds. And then there's the protostar, I think that's how you say it. But those are the young forming stars that are like starting to grow. And then there's just the main sequence stars. And those are just the ones that are producing energy all the time, I believe. And then lumen density or lumen something, That's the size and the temperature of a star and what it needs. But that was like enough about stars. And then the labs we did were the pendulum lab, which was the little pendulum that goes back and forth. And you obviously know, but just for me knowing. I used blue tape for the bob for my first set. And then I hung it on a closet rod to try to get it to work. And it worked like pretty good, I'd say, for doing it for the first time. And then the second one I did a small wrench for the bob, but I just kept it the same with other stuff. And I didn't notice a big difference in time for that. And then we did our observing moon lab, which was really fun. Something I really liked and enjoyed because I've never done it before. But yeah, and then I got to learn about the different moons. Like the new moon is basically pretty much all dark with a little bit of light starting. And then you go to the next phase of the moon, which is the waxing crescent. And that's like a little more light, but it's still like pretty dark. I'd say like probably a little more dark than you'd think. Oh, excuse me. And then the first quarter, which is like 25% done. It's weird to think about it that way. That's only 25% done, even though it's pretty much like 50-50 dark and light on each side. But that's just 25% of the cycle from the new moon to the full moon. And then after the first quarter is done, you go to the waxing gibbous, which is a little less more dark and a lot more bright. I think it's like 51 to 99% full is what you can think about brightness. And then after that is just the full moon total. And then the other thing we did too was studying the stars as a lab, which I don't know if you're going to watch this or do this, but I was just wondering, I'll also type it out, but it would be awesome if you could just grade the lab for that, for the lab studying the stars. But for that one, we just talked about the stars, the types that they had, like their main sequence, if they're a main sequence, if they're a giant, if they're a white dwarf, and then I just plotted them on a graph. Yeah, and then I just think I'll just wrap it up by, like, astronomy is really fun. I just not, like, I don't really pay attention normally to like the moon and the planets and the stars that much. Like, if I got told by a friend, I got told by a friend. But it's cool now that after taking this class and all the opportunities it gave me, like, I'm able to look in the stars. I'll know where like the moon's rotating in what direction, or like what stars, or maybe what if I do a little more research than normal. But overall, it was a good class, and I had lots of fun just enjoying it. And that's it.